Hello dear students, let's see in this video types of pushdown automata. Now as you see I have written there are two types of pushdown automata. The first one is pushdown automata by final state. This is what we were learning in all these videos because you recall that in all the PDAs, rather three PDAs we developed till now, in all those PDAs there was a state which was double circled. That means in all these PDAs that we developed there was a final state. But then you will be surprised to know that we can construct a PDA without a final state. That means PDA need not have a final state. PDA without accepting state or without final state. Such a PDA is called PDA by empty store. Empty store means empty stack. Okay. Now, before I proceed, let me tell you that both these PDAs are equivalent. That means if you can solve a problem like a raised to n, b raised to n such that n is greater than or equal to 1. We solved this problem using this PDA. That was our first problem. And that PDA had final state, isn't it? We can solve the same problem using PDA by empty store. Both PDAs are absolutely equivalent. It depends on our taste which type of PDA we would like to construct. But then is there any difference as far as their working is concerned? By power, we say, by power they are same. That means both can solve same amount of problems or same problems can be solved by both the machines. But what about working? Just check. For PDA by final state that we have been seeing, a string W is accepted by this PDA only if two conditions are satisfied. First is if the input is over or finished, that means if we reach epsilon on the input, and second condition is PDA must be entering the final state. PDA must be in the final state. Both these conditions must satisfy. Which one? First one, the input is finished, and second, PDA must be in the final state. Whereas, what is the condition or what is the working of PDA by empty store? See, the string W is accepted if two conditions occur. First is the input is finished, which is same as this, epsilon is reached, but the second is that the stack is empty. Whereas here the second condition in the case of PDF by final state was PDA must be in the final state, but here the stack should be empty. It's so easy. Trust me, it is so easy. You will understand as soon as we revisit our first problem that we solved on PDA. A raised to n, b raised to n, such that n is greater than or equal to 1. This was the PDA we constructed. For every a, we are pushing x. For every a, we push x. Just check for consecutive a also, we push x. And for every b, we pop x. For every b, we pop x. And for epsilon input, when the input is finished, and if the top is z0, we keep that z0 as it is and enter the final state. Now, what if I say in this example, what if I say that if the input is over, that means we have read all A and all B and we have reached epsilon. Just notice for A we have pushed x, for A we have pushed x, for B we have popped x, for B we have popped x, and now we have reached epsilon. So obviously Z0 is only pending on the stack. We pushed x but we popped x and now only Z0 is pending. Now what if we say that instead of keeping that Z0 as it is and entering final state, what if we say, just observe, what if we say that on epsilon, when the input is over, just check if the input is over on reaching epsilon, and if the top is Z0, on reaching epsilon, top is Z0, we will pop that Z0 also. We will remove that Z0 and will stay in Q1. Just notice in this PDA there is no final state. No final state. But this PDA is valid. This PDA is absolutely right. We have defined a new transition on Q1, and the resultant PDA we get is this. Exactly the same. Just see what's the change we have done. The only change we have done is on this epsilon and Z0, we were sending the machine to final state Q2. You remember? But now we are looping in Q1 and we are saying that when nothing is remaining in the input and Z0 is the top of the stack, then pop that Z0 and remain in Q1. Just see, this is exactly the PDA that has been drawn here on the top. But then how does it work? What is the working of this? Just see, if I take a small input AB, you know this is valid input. And what is top of the stack initially? Z0. Now on reading this A, you know we are going to push X and we are going to stay in Q0. On top of Z0, we have pushed X, just check, and we will stay in Q0. Now on reading B, on reading this B, we are going to move to Q1. But most importantly, on reading B, that X is going to be popped. So this X is popped from the stack and we are now into Q1. After reading this B and after removing X, we are into Q1. Now watch, in Q1 state, we are reading epsilon, we are reading nothing, we are reading empty string. Then top has to be Z0 we have defined, and really true, top is Z0. This X which we had pushed has been popped. This B has cancelled out this A, and in Q1 state, when we are reading nothing epsilon, in Q1 state, when we are reading epsilon, top is Z0. Then what we are doing is we are popping this Z0 also. Just check this epsilon and we stay in Q1. We stay in Q1. So what is the state now on reaching end of input? That is on reaching epsilon. What has happened? The Z0, the top of the stack, is also removed. Also removed. I hope you are understanding. Also removed. So stack is empty. Stack has really genuinely become empty. Stack is empty. And V, or rather PDA, is in Q1 state. Just check. There is no final state here. We have not drawn any double circle. But importantly, two things have been satisfied. One, input is over. Just check, we have reached epsilon. Input is over. Second, the stack is empty. If both conditions are satisfied, then we say that the input is acceptable. See, the input must be finished and stack must be empty. Let's understand this again with the same example, a raised to n, b raised to n, such that n is greater than or equal to 1. I don't mind drawing the same PDA. For a z0 we push x, and for a x, this is consecutive a, we are pushing x. But for b, top is x, we pop that b. In Q1, we loop around. For any b, top should be x, and we pop. And for empty, that is end of the string, if top is z0 only, then we pop that. This is PDA. This is PDA by empty store. This does not have any final state, but still it is equivalent to the PDA that we had drawn earlier. Okay, let's see how this works. Suppose we have a double b. Just check, this is invalid. So PDA must reject this. So what's the stack initially? Z0. We are in Q0 state. Q0, give me some time, wait a minute. I'll just erase a few things, make some room on the board. Okay, Q0 is reading A and top is Z0, correct? Q0 is reading A, top is Z0. So we will loop in Q0 and we will push X. Okay, now we are still in Q0. So Q0 is reading a B, check the character, check the letter B, and top is X. So Q0 is reading B, top is X. So what are we going to do? We are going to pop that X, remove that X, and we will enter Q1. we will be entering this Q1 state. Okay, so we are in Q1 state. Just check very carefully. We are in Q1 state and we are about to read this next B. In Q1 state, we are reading B, but top is Z0. Oh, good Lord, look at that. Now the top is Z0. Hello, when you are reading a B, you should have A pending, but now you have Z0. You don't have any X pending. So do you have any such triplet? You just watch. In Q1, while reading B, top should be Z0. You don't have that. You have B comma X. You don't have B comma Z0. Or you have epsilon comma Z0. You don't have B comma Z0. So machine will halt in this state. Correct? Machine halts because it doesn't know what action to take. You have not defined this triplet at all. So machine halts in Q1. So what will you say about this? Hello? Machine has halted in Q1. Is this string acceptable? Listen, two conditions must be satisfied. A, input must be finished. Input must be finished. And second, stack must be empty. When the input is finished, stack must be empty. Here, neither of the conditions are satisfied. Neither the input is finished because we are stuck at this B. You observe, for this B, we didn't know what action to take. Input is not finished and stack is also not empty. I hope you are understanding. Let's understand. Give me some time. Just wait. I'll just clean a few things. This example will be more interesting and you will know exactly. I mean, you already understood. I am confident about what is PDA by empty store. But just observe. Suppose I have got a string like this, double A and then B. Just check this. So in Q0 state, initially the stack is going to contain Z0. In Q0, we are reading A, top is Z0. So what are we doing? We are pushing X and we are remaining in Q0. Now in Q0, we are again reading A, but top is X. So we are pushing one more X and remaining in Q0. But now in Q0, we are reading a B and top is X. In Q0, we are reading a B, top is X, and we will pop one X from the stack. So B has cancelled out an A, but we have entered Q1 state. Now the things turn interesting. In Q1, you are reading epsilon. Just check. In Q1, you are reading epsilon. Watch this. But if you are reading epsilon, the top has to be Z0, but note that the top is X. Just tell me, is the input finished? Yes, input is finished because we have reached epsilon. See, the first condition is satisfied. But is the stack empty? No, stack isn't empty because stack is still containing X. Just check this. Both conditions must be satisfied, but one of the conditions is not satisfied. So this string is rejected. I hope you are understanding. Input must be finished and stack must be empty. If that's true, then the input is valid. Just check. The two types of PDA are always equivalent. So what was the second problem that we solved? You recall it was a raised to n, b raised to 2n, such that n is greater than or equal to 1. What was the PDA we constructed? The idea was, for first a, when the top is z0, we will push x 2 times because we were remembering each a 2 times because number of b's must be double the number of a's. For any a which occurs consecutively, we will push x again 2 times. So this x is restored and 2 more occurrences of x are pushed. But for every b, top has to be x and we will pop 1x. And in Q1, we again loop for b. For every b, we will pop x, correct? But when we reach empty string, top has to be z0. That means whatever you have pushed should have been popped, and we will keep z0 as it is and we will enter Q2 state. This was PDA by final state, correct? Now, what if you want to construct PDA by empty store? What you have to do is simply say that if end of the string is reached, if epsilon is reached, then there is no final state, isn't it? If epsilon is reached and top is Z0, then remove that Z0 also so that the stack becomes empty. If the input is over, stack becomes empty only if top is Z0, and you can loop here. So if the input is finished, and top is Z0 at that time, when the input is finished, top is Z0, then pop Z0 also. If you pop this Z0, then stack will be empty. Then input is also finished, stack is also empty, then you will accept the string. But note here such a big point that if the input is finished, top of the stack should be Z0, only then you can pop. Because if the top is Z0, that means whatever you pushed has been popped successfully. I hope you have understood how these two PDAs are equivalent. Okay, and I am confident on your part that any PDA by final state now can be converted to PDA by empty store. We may practice this in the coming videos more and more. Thank you very much.